This video will discuss different types of angle relationships. Some pairs of angles are special because of how they are positioned in relationship to each other. 3 of these angle pairs are described below. So the first angle pair we'll discuss are adjacent angles. So adjacent angles are 2 angles that lie in the same plane and have a common vertex and a common side, but no common interior points. So let's break this down. Adjacent angles are 2 angles that lie. The first thing it tells us is the same plane. So you can think of a plane as a 2-dimensional figure. So like a piece of paper would be a plane. They have a common vertex. So this would be the vertex. And a common side. So here's our common side in between angle 1 and 2, but no common interior points. So it's saying that the points inside of angle 2, these points, are not common with these points. No common interior points. So angles 1 and 2 in this case are adjacent angles. Angles 1 and 2 in the next figure, they have the same vertex, they share a common side, and they do not have any common interior points. So we can say those are adjacent as well. Here's some non-examples. Angle 3 and ABC, so here's angle 3, here's angle ABC. So they do share a common side, but the points inside ABC overlap with the points inside 3. So they do have common interior points. So it's not going to be adjacent angles. The next non-example is angle 3 and ABC, and these ones actually have a different vertex. So B is the vertex of ABC, and 3 has this vertex right here. So since they have a different vertex, they are not adjacent angles. The next angle relationship we're going to discuss is a linear pair. A linear pair is a pair of adjacent angles with non-common sides that are opposite rays. So it's a pair of adjacent angles, so it has to adhere to the same definition we just talked about, adjacent angles. And it's a linear pair when the non-common sides, so these would be our non-common sides, are opposite rays. So if they're opposite rays, that means that they form a line. And you can remember that easily because it says linear pair. So line is in the word linear pair. It means that the 2 angles together form the full angle of a line. So that'd be 180 degrees. A non-example would be ADB, this angle, and ADC, this angle. These have a common vertex, they have a common side, but their rays are not opposite. They are not opposite rays. So it does not adhere to this rule. So they don't form a line. So they are not a linear pair. Vertical angles are 2 non-adjacent angles, so they're not next to each other, formed by 2 intersecting lines. So if we look at this figure, 1 and 2 are adjacent, and 3 and 4 are adjacent. A non-example would be AEB and DEC. So these 2 angles are not going to be vertical angles because they're not formed by 2 intersecting lines. We have the line AC, but EB, the rays EB and ED are not opposite, so they do not form a line. Lastly, let's look at an example. Name an angle pair that satisfies each condition. So let's look at 2 acute adjacent angles. So acute adjacent angles, first we need to know what an acute angle is. So an acute angle is any angle that is less than 90 degrees. So in green, I'm going to put our acute angles. So we have HJK, we have this one here, this one here, and this one here. These are all our angles that are less than 90 degrees. So adjacent, meaning that they share a common vertex, so they're next to each other, are going to be LMN and MJN. These two angles are adjacent, so they are acute adjacent angles. And also OJN, this one, is next to this one. So those ones are going to be adjacent as well. The last thing we'll look at is two obtuse vertical angles. So obtuse means greater than 90 degrees. And I'm going to erase what we have here. So if we look at vertical angles are formed by two intersecting lines. So let's look at line HM and NK. So these two lines form vertical angles here, HJN and KJM. And since the angles are greater than 90 degrees, these are called obtuse vertical angles.